All right, let's dive right into an explainer that completely flips how we look at industrial power. We're pulling this straight from the latest First Screens consulting report, and we are going to look at a massive shift happening right now in how commercial and industrial facilities manage their electricity. And trust me, the financial implications here, they're absolutely massive. What if a battery could pay for itself in just 5 years, all while rescuing the national grid? That's the exact question we're answering today. We're going to bust the myth that industrial batteries are just, glorified diesel generators. For a long time, energy storage at a factory or a hospital was basically just seen as an emergency backup. But as we're about to see, modern battery systems are active, profit-generating assets. Get this. 20 to 30% of a facility's monthly power bill is determined by just a few minutes of peak use. It's kind of a shocking fact, right? Imagine running a massive manufacturing plant for 30 days straight, but nearly a third of your power cost is dictated by a single random 15-minute window where all your machines just happen to spin up at the exact same time. It's a huge structural cost problem, and it is begging to be solved. To break down this massive transition, we've structured our explainer into 6 quick chapters. We'll cover the costly power problem, the behind-the-meter battery solution, beating the demand charge, the brain behind the battery, the financial payback, and finally, fixing India's duck curve. Let's get into it. Section 1. The costly power problem. Let's pinpoint the immediate pain keeping commercial facility owners awake at night. So what is a demand charge? It's a fee based on the maximum electricity demand recorded during your billing period, usually measured in 15 or 30-minute intervals. The crucial point here is that you aren't just paying for the total energy you consume. You're actually being penalized heavily for the intensity of your demand spikes. If your facility draws a massive surge of power for just a 15-minute interval, the utility company hits you with a premium for that peak capacity, even if your average use is super low the rest of the month. Moving on to Section 2. The behind-the-meter battery solution. This brings us to the strategic frontier of energy storage, designed specifically to eliminate those spikes. So what does behind-the-meter, or BTM, actually mean? It's energy storage deployed on-site at commercial buildings or factories, placing power control directly in the consumer's hands. We need to be clear here. We aren't talking about massive utility substations. We're talking about large batteries sitting right in your facility's backyard. Behind the meter means it's on your side of the utility meter. It's your asset. You control the power dynamics and costs, rather than relying entirely on the grid. India's energy transition is shifting in a big way, from front-of-the-meter grid projects to behind-the-meter facility solutions. Historically, India's storage stock was all about central grids and utility-scale batteries. But now, the momentum has aggressively shifted. Facilities are pairing rooftop solar with their own on-site batteries to manage local demand directly. Section 3. Beating the demand charge. Let's look at exactly how this technology acts as an anchor to sink those exorbitant monthly costs. Let's talk about the actual math for a 5 MVA consumer before and after installing a battery energy storage system. The demand charge shrinks from 0.82 crore down to 0.54 crore, just by shaving off 900 kilowatts of peak demand. This is real data from the first green model for a large-scale industrial consumer. By using the battery to supply power during those intense 15-minute spikes, the facility never pulls that peak load from the grid. So your energy charges stay roughly the same, but your demand charge absolutely plummets. When you compare a before battery bill of 3.35 crore to an after battery bill of 3.01 crore, you're looking at a pure 0.34 crore monthly savings. That is a 10.1% bill reduction right off the top. It's a massive operational cost saving. And the best part? It all happens automatically, without the facility having to slow down production or even turn off the lights. But how does the system know when to act to actually save you that money? That brings us to Section 4, the brain behind the battery. You see, you can't just plug a giant lithium-ion box into a factory and hope it figures things out. The battery itself is just the brawn. The real magic happens with the Energy Management System, or EMS. Think of it as the brain of the whole operation. It acts like an orchestra conductor, monitoring the grid connection, tracking rooftop solar generation, and deciding moment by moment whether to charge the battery, send power to critical loads, or discharge to shave the peak. The EMS operates on a brilliant 4-step logic loop to ensure your facility never crosses that costly contract demand threshold. First, it forecasts the load using historical data to predict tomorrow's energy needs. Second, it detects the specific peak windows where demand spikes are expected. Third, it optimizes the charge and discharge schedule,
basically charging up at night when electricity is cheap and discharging during the peak. And fourth, it always protects a minimum state of charge reserve, just in case there's a sudden grid outage and you need emergency backup. Section 5. The financial payback. Okay, so the tech works beautifully, but does the business case actually make sense for an investor? Well, for a standard 2.5 megawatt system, the simple payback period is an incredibly lean 5.1 years. In the world of heavy industrial infrastructure and large capital expenditures, a payback period hovering right around 5 years is highly attractive, especially when you consider this is for an asset that has a 12 to 15-year design life.
Let's break down the base case financial model. You start with a gross capital expenditure of 14.50 crore rupees. But when you stack the demand savings with tariff arbitrage and offsetting diesel costs, things get really interesting. The system captures cheaper off-peak electricity to use during expensive peak hours and replaces dirty, expensive diesel generators during short outages. All of that yields a net operating benefit of 2.89 crore rupees every single year. That means you hit a 14.2% project internal rate of return, generating positive operating cash flow from year one.
Finally, let's zoom out a bit. Section 6, Fixing India's Duck Curve. Let's see how thousands of these individual factory decisions impact the entire national power grid. You might have heard of India's infamous duck curve. It's the huge mismatch between a massive surplus of midday solar power and a massive demand spike that hits right around 8 p.m. During the day, there's so much solar power on the grid that demand drops off. But as soon as the sun sets, demand absolutely rockets up to around 256 gigawatts as everyone turns on their lights and appliances. Behind-the-meter batteries perfectly balance this out. They charge during the day, literally soaking up that excess solar, and then discharge at night, completely flattening that steep, problematic curve.
What's amazing is that by simply acting in their own financial self-interest to lower their monthly bills, these commercial facilities collectively create a massive, distributed flexibility resource that stabilizes the entire national grid. If we reach just 20% penetration of these systems, we're looking at shaving up to 24 gigawatts off the national peak demand. Plus, we'd be shifting 58.3 gigawatt hours of daily energy from low-value periods to high-value periods. This directly leads to an improved system load factor, less stress on the grid, and way fewer blackouts.
There's a quote from the report that really nails this whole paradigm shift. Behind-the-meter battery storage should be treated as a performance-driven energy solution, not as a battery commodity. It's so true. You aren't just buying a box of lithium-ion cells. You're investing in a smart, dynamic energy asset that continuously negotiates with the grid to save you money. The hardware stores the energy, sure, but the smart dispatch software is what actually monetizes it. So we leave you with this question. If commercial facilities can transform from grid burdens into profit-generating power assets, how does this redefine the future of real estate and India's energy independence? Think about that as you consider your own energy strategies moving forward. Because this transition, it isn't just coming, it's already sitting right there behind the meter. The line between being a consumer of power and a manager of power is totally disappearing. I hope this explainer gave you a really clear view of how energy storage is completely reshaping industrial power. Keep learning, stay curious, and we'll catch you next time.